All right, so hey, can we agree to try to have a more civilized conversation this time? I will on my end do my best. We can devolve as much as we'd like to, but can we always agree right now ahead of time that we'll bring it back to a civilized point before before we leave here? Is that okay?
Yeah, great.
All right, great. So all right. So how are you doing today, sir?
I'm great, and I'd be great if you could continue not cursing and not insulting. That'd be great.
I cannot guarantee that. Sorry.
Well,
And if
look.
everyone out, so this is between me and Team Skeptic, that would be great. I don't
Oh no,
Well,
sir! I have many bones to pick with you myself.
Well, hold on.
Okay,
Let me do something. Nathan.
Talk to me. Who
Nathan.
wants to talk to me? Am I
Yeah,
talking
yeah.
to White Flat Earth?
Well,
Am I talking to Team Skeptic? Everyone else, mute out.
Hey Nathan, give me 1 second, okay? I'm gonna ask.
No one tells me what to do, mate.
Hold on. Listen, I'm gonna ask Radical and Jennifer to just leave for a moment. Jennifer already stepped out. I would have given Jennifer a chance to say her goodbyes. Radical, can I get you just a? Well, Radical, you can stay. Just if you'll mute for the time being, so that way we can
sure.
have this discussion, and then we'll bring you back in so that we can all have a general discussion at the end. Okay.
I'll just jump out for a moment and watch the show because this is going to be fun.
I have many questions for Nathan.
Okay.
I'll see you guys later.
Here's what I'm going to do. I'll let Nathan and Fight the Flat Earth start with the conversation, and then I'll try to stay out of it as much as possible to keep it one-on-one so you don't feel like we're tag teaming up on you or trying to bully you or anything like that, okay? Does that work for you?
Sounds good.
Okay.
How you doing today, Nathan?
I'm great. Thanks for asking, brother. How are you?
I'm fine. I want to know why you're still pushing Flat Earth when it's quite clear that that's not the truth.
Well, we just did a 17-mile laser experiment in Salton Sea. We held the laser 3 feet off the ground, and you could see it from the other side of the lake 17 miles away. Now, if Ursa ball 24,901 miles around, Craig, how much curvature should we see 3 feet off the ground? From
More importantly, what's the specs of the laser?
It doesn't matter what kind
Oh,
of
it most
laser.
certainly does matter. If you can tell me the specs of the laser, that'd be fantastic.
Craig, if you want, you can go to my channel. We stood on one side of a lake 17 miles wide, and you can see...
Okay, I understand the concept of what you're saying, Nathan. I would like to know the specs of the laser that you were using.
That's great. It's totally irrelevant.
But it's really not, though, because you know that really affects what kind of result you're going to get. So to be accurate to give you an answer to that question, I would need to know the specs of the laser that you were using. Do you know the specs of the laser that you were using?
No, I don't.
Well, how can you perform an experiment if you don't know the specs of what you're using?
Because I know the curvature formula.
That's not... Well, you don't know the curvature formula. We all know that. But you also can't do an experiment if you don't know the specs of the equipment that you are using.
So you have to know exactly what kind of laser you're using to conduct a test on curvature? Cool story.
100%, yes.
Can I just interject one thing?
Story.
Yeah, go ahead, team.
Can I just interject one thing? The reason why it's important to know the specs on the lasers because laser light has a diffraction. So what you're going to do is when you start out with the beam at one size, depending upon how far away you go, the beam is going to expand in its size. So certain specs of certain lasers keep that beam tighter for longer distances. That's why it's important to know this because when you're looking at something, right, you yourself, if you're on one side and you're observing this light coming to you, you don't know that the light's huge. All you do is see the photons that are coming to you. You don't see the photons that are going by you next to you. So to you, the light doesn't look like it got any bigger. But more people in that area can see the light because the light has actually increased, the laser has increased in size. So when you're talking about something that shouldn't be seen because it's hidden by curvature, you also have to account for how much the laser light is going to spread out as it goes across that distance. Once you know how much that laser light is going to spread out, you know what your range is of what you should and should not see. That's why it's important to know these things. It's important for us to know it so that we can verify or debunk your claim. It has nothing to do with trying to get you in a gotcha moment.
We can see the laser source from the other side of the lake.
Right.
Yeah, and as Team was just explaining, if you don't know the specs of the laser, then there's no way whether you can tell whether you were supposed to be able to see that light from 17 miles away, because the light could have diffracted enough for it to be able to be seen. Really, this was the exact same problem that Jeranism had when he attempted to do the experiment. I mean, you've all seen the documentary.
You think
but also, Nathan, I would like to point out one other thing. Do you remember when we debated on the Non Sequitur show, and you were saying I shouldn't be able to see the stars because of how far away they are and how big they are? Well,
wait. You think it diffracts around the curvature? That's why you need to know what kind of laser we used?
Yes.
No. Okay, hold on.
Okay, team, take it. Sorry.
No. The diffraction is not around. Okay, so first off, yes, light does diffract around points. So you can test this with anything. You can put up something and you'll see the light where you shouldn't see it. It looks like the light comes around a corner. That's diffraction. So that does occur, but that's not what I'm talking about. I'm talking about the way the laser light spreads out as it gets further away from any source. You can do this. This doesn't just happen at on the curve of the Earth. This happens anywhere with every light you'll ever see. Any light you shine is going to get larger as it gets further away. This happens with lasers as well.
Yes. You guys aren't understanding what I'm saying. You stand on one side of the lake and you can see the source of the laser. It's not huge. It's not enormously big.
No, you won't see it huge. That's what I'm saying. You won't see it huge. You're still only going to see the photons that go into your light, or into your eye. I'm sorry. So you're not going to see the photons that are going by your head. But if you had a whiteboard behind you and you were looking from in front of you, you would see the laser all the way around your head. You would see it probably, I mean, depending upon how far away you go. Let's say you said 17 miles, right? I mean, that's a pretty large distance for a a laser that doesn't cost thousands of dollars, that can keep the beam down to, at that point, only about 1 or 2 feet. You know, you started out with something that was millimeters.
The laser's diffracting and curving around the lake. Is that what you guys are saying?
So I'm saying that the laser is going to diffract in every situation, and I'm thinking it's diffract. It's the way a light beam will open up as it goes further away. I'm thinking it's diffraction, but that is going to happen regardless. The refraction part is a whole different thing. That you're going to get diffraction even when refraction is not there. Refraction is not dependent upon diffraction.
So what? You think you don't get diffraction when you look at an object with your eyes? There's a diffraction limit, dude.
Right. So what we're trying to say is that once we know what the diffraction of the laser, once we know the specs on the laser, we will then know whether this is something that's supposed to be seen or not. We can't tell you whether it was supposed to be seen without the information. So until that information is given, there's no way.
We can tell you the amount of curvature there's supposed to be. We can tell you, what you should and shouldn't be able to see, but without knowing the specs of the laser and how much it would diffract over a certain distance, we can't tell you for sure whether it should or shouldn't be able to be seen. And this is an important part of science that you seem to be missing. As far as you're concerned, I see a light, therefore I've done it. No, there's a lot more variables and everything to be taken into account. You understand that, right?
Does the laser diffract around the alleged hump of curvature, or does the light just separate as it leaves, and as you're on the other side of the lake, you're looking at the source of the laser, where the laser is coming from? So it doesn't matter how big the ray is when it gets to the other side of the lake. I'm looking at the light pen, the laser source, at the other side of the lake, and you guys claim there's a wall of water between us. You guys claim...
No one claims there's a wall of water between you, Nathan. Nobody ever claims that.
That's what you guys claim curvature.
No. Please stop misrepresenting the model. If you need to argue against the model, you first have to understand it. And nobody claims there's a wall of water.
Okay, let me say what you should be saying, because when flat earthers say that there's a bulge or a wall of water that should be in front, that's saying that if we were to take the 2 points, okay, and we were to make those 2 points and draw a straight line between those 2 points, what amount of the curvature would go over that line? That's the amount that should get in the way. Now at 17 miles, you're not looking at a lot of bulge that's supposed to be getting in there.
How much bulge are we looking at 17 miles? I mean, that's more than 10 miles, right? So we should see more than 60 feet of curvature, right?
Right, but that's still not that much. Without knowing how much the laser light, without knowing how much the laser light diffracts at the whatever the distance is between the observer and the horizon.
A 5-story building wall of water, dude.
You don't know that. You can't tell me. You can't tell me that without giving me the specs. And at the same time, did y'all guys? Now, Nathan, let me tell you what I hold. Let me explain to you what I think, what I consider evidence to support your position. Okay, you make this observation. At this point, it's just an observation. You said, "Look, I see this," and you say you shouldn't be able to see it, but that's just you saying that. Okay. Now, how come you shouldn't be able to see this? Do you have the refractive indexes taken? Did you even bother to do that? This is a simple process. This legitimizes your experiment. Did you take refractive indexes ahead of time? Did you also account for diffraction of the laser? Go ahead.
If the laser's refracting, then it's refracting downward, making it even harder to see.
No, it makes it. That's not how refraction works on a globe. On a circle, if you didn't diffract the light, or if you didn't refract the light down, the light would go over your head and off into space. That's what our model says should happen. So refraction absolutely explains what we're observing. If the refractive indexes support that, but you didn't take refractive index measurements.
You're assuming that refraction's bending around the curvature. No, the light bends down towards the Earth and goes straight into the Earth.
Right.
So it doesn't go around the curvature. The light bends, and instead of going in a straight line across the lake, it goes directly into the water.
Okay, so let me ask you this. Let me ask you this then. If there is no refraction, where should the light go on the globe Earth? If it's 17 miles away and they're shooting it at eye level, where should the light go? Should it go over my head or should it go under my head?
Yeah, it should go way over your head.
Right. And what does refraction do? It bends it which way? You just said it. I'm going to let you say it again. It bends it which way?
But it doesn't bend it around a curve. It bends it down towards
right.
the Earth.
Okay, exactly. That's what we're saying. That we are now in agreement at this point. I'm saying that the light should go over my head. The atmosphere is bending the light down, and there's a diffraction. There's a spreading of the light as well. These two observational facts that can be explained with Snell's law and just basic light wave propagation. Okay, so we take those two and it matches what is possible. I'm not saying that that's proof that the Earth is a globe. I'm saying that. Listen, I'm not.
Wait. 17 miles. Let's do the math here on the curvature formula. Can someone pull up an observer at 3 feet of height?
Let me correct myself. Nathan, can I correct myself one time? Because I've been using the wrong word. It's divergence, not diffraction. I'm sorry. It's laser beam divergence. I knew I was picking the wrong word, but this was impromptu. But thank you very much, Gary Little, for pointing that out. If no one else has, but go ahead, Nathan.
Quick,
I'm sorry.
How much curvature, 3 feet off the ground, at 17 miles, guys, are you claiming this certain type of laser might bend around? Like, we're talking about over 100 feet of curvature, guys. And you can see it 3 feet off the ground.
Okay,
the globe is so dead in the water, dude. Literally, in the water.
So I'm telling you now that using Snell's law, okay, I can tell you that this is possible. Now, what I need from you to tell me that that's not possible is I need measurements that show the refractive index on the day and time that you took the test. These are not hard. These are you can talk to any geodesic surveyor. They'll tell you about different points. Anywhere you go, there's a map where you can use different points where they know the height and distance to those points, and you can look at it with a surveying equipment, and you can tell where it is from where it should be. And using that information, you can build a refractive index so that you can say, when I go, no, it's refraction, you go, no, here's the refractive indexes on the day, here's the data I took, so it's not refraction. And then I have no argument.
Yep. How much curvature should there be at 17 miles?
I don't know the answer off the top of my head.
You don't? Oh, well, go ahead, do the math, skeptic. You're a smart guy. You know the curvature formula. How much curvature should there be at 17 miles?
Well, if you're talking about the curvature formula that flat earthers use of 8 inches per mile squared, that's not the right one.
Why don't you tell me on a ball? You just use AutoCAD. AutoCAD will tell you exactly how much.
I can do that. I'll just use Metabunk because theirs is. I'm not even going to take the refraction. I'm not going to take. No. I'm not going to do any refraction. I'm just going to do the curve at the certain distance.
Got so embarrassed. Nathan Oakley took a giant dump on his curvature calculator because Metabunk admits R is assumed. It's never been proven. And
yeah, but do you have any proof that R is not what it is? That's the case. We have scientific backing. We have mathematical
can definitely
backing.
verify what R is 100%. Like there's so many ways to do that.
No. You can't deduce it either unless you're working.
No. It's verified. We know what it is.
So let's not even worry about that point right now, because you asked me on the globe, and the globe has a radius of 4,000 miles roughly. So that's our model. So we're going to go with what our model is, because you asked for the drop with our model, right? You said from 3 feet from 3 feet up, correct? 17 miles. It says I'm going to look at non-refracted, so that way we don't. The geometric horizon is 2.2 miles away, and the drop, it says, is 192.72 feet. So 147.63 feet is hidden. So that's what we're looking at. 150 feet of hidden. That's nothing.
Yeah, and that is nothing. 3 feet off the ground, team. We held the laser 3 feet off the ground, and you're asking, well, what kind of laser? Because it might have been around 150 feet of curvature.
Because it can.
That is embarrassing.
No, it's embarrassing that you don't understand what I'm saying, that you can easily tell me I'm wrong just by providing certain information. Right now I'm
to test like that without actually getting the correct information about what was going on.
I don't have what you need, so let's move on.
No, that's fine. This is just a conversation. Okay, right. We're not here to prove anything tonight. We're just here to have a conversation.
Let me point out the fact that Nathan contradicts himself a lot here, because you're saying that you could see the laser pointer from 17 miles away, right?
I'm not saying it. We have the video.
Okay. We're just giving you the benefit of the doubt right now.
At the same time, Nathan, you're telling me that I shouldn't be able to see the light from stars based on how far away they are. So why should I be able to see a tiny little laser pointer 17 miles away, yet I shouldn't be able to see the light from the stars?
Well, because the laser is only 17 miles. You're talking about stars, the nearest one being 2.5 light years away. Now, like, for example, take the sun, right? Light works off an inverse square law. So if you move the sun twice as far away as where you are, it's 1/4 as bright as it is. And if you move it again twice as far as that, it's going to go to 1/8 as bright. Not just that, but the angular size in the sky decreases. So right now, when you look at the sun, it takes up about 1/2 degree of the sky. You move it away another 9 minutes from Earth, and it takes up about 1/4 degree in the sky. You move it away another, and you're looking at 1/8 degree in the sky, and and we're not even at a light hour.
Okay, but still, using your inverse square law and the size of the emitter of the laser, you shouldn't be able to see the light because you can't see the emitter. Red Rhetoric and Sean Hufford took some images from a couple of miles out above a lake, and they pointed a laser at the drone from when it was flying above the lake. And then they did the calculations based on the pixel, what the drone's camera could actually see. The drone could in no way see the emitter of the laser, yet it was still able to see the light from the laser. So my whole point here is that you will say one thing when it suits you in one way, but you completely ignore that same point when it doesn't suit you another way. You can't see the source of the light. You can see the light because the light is the thing that's traveling.
Go watch the video.
Fantastic answer. Well done. You convinced me.
Go watch the video.
Well, like I said, unless you provide any information about the laser you use, and that's fine, you can provide that now. That's what the good thing about the description is you can go back and edit the description. Now you can't take the refractive indexes from that night, and that's totally cool. I'm not, like I said, I'm not here to say that your observation is fake. I'm just saying without you telling us what information you have, we cannot verify that this observation does not make sense on the globe Earth as well. Okay, so next time you do that, yeah.
Okay, you guys are claiming you need to know the refractive index and the type of laser to figure out if it can bend around 150 feet of water, dude.
Yes.
Yes. Do you know what?
Okay. But Nathan, hold on, fight the fighters. Let me tell you something. Let me say something. Nathan, listen. If you want me to not be able to tell you that this is possible, listen. Okay, that's fine. That's cool. I would like to know next time when you do that, so I can at least see the data. You know, if I am all about the truth. I don't care what anybody says. I'm all about the truth. Okay. If I find somebody lying, I've called out globe earthers for lying before when they've lied on their channels. I've called them out for making mistakes. I've had people call me out for making my mistakes. My mistakes are genuine mistakes. I hold the intellectual, honest position. So if I don't know something, I'm not going to try to bullshit you. I'm just going to say I don't know. In this situation, I think it would be a good idea for you to research what it takes to make that a valid scientific observation, not just a physical observation. Because I'm not here to tell you that you're wrong. I'm not here to say you're faking it. You made this shit up. There'll be a lot of globe earthers that'll say that to you. I'm saying you didn't give me enough information to verify or prove you wrong. If you're wrong, I'm gonna call you out and say you're wrong. If you're right, I'm going to say you're right.
Guys, real quick. What type of laser and refractive index would allow for the laser to be bending around 100-foot amount of curvature, 150 feet?
Well, that's two variables. That's two variables you're trying to take to make one answer. And with the way that those variables work, there's going to be, you know, a higher refractive index will require a lower laser divergence. A lower refractive index will require a higher laser divergence.
Listen real quick. If you're looking at the horizon, and it's the edge of the curvature of the Earth, it's that's R. The horizon is R, right?
Okay.
As you shine a laser at R, and it starts refracting, the laser goes down. It doesn't go around the curvature or around the horizon. It goes down towards the water.
No. Okay, so you're making this assumption that that light hits this for some reason, goes to the horizon and takes this sharp angle down. That's not what happens. No. You need to understand Snell's law before you speak on that refraction. Then.
And grading criteria and everything as well.
Colors that'll slow down are the shorter wavelengths. They get stuck in the atmosphere first. Yeah, that's why you get a green flash at sunset. Is because the shorter wavelengths have been slowed down first. So I understand how refraction works. It directly changes the angle of the light. It doesn't bend the light.
Yes, it does. It bends the light. Okay, hold on. No. Okay, so yes, you're right when you have a distinct drop from one refractive index to the next. Okay, so let's say you're dealing with a glass of water. What you have is you have air, and then you have a distinct layer where the air stops and the water starts, and then you have a distinct layer where the water stops and the glass starts. The atmosphere is not like that. The atmosphere is fluid. You're starting the light inside the atmosphere, and the atmosphere and the light's just following the atmosphere. This is the refractive index that causes it to bend down, because you do have these like temperature variations in the atmosphere, which is why people do these experiments over fucking water. You don't see these experiments being done over land, and there's other reasons you can't do it over land, because you have any minor bumps in the land, you'll get in the way of the laser. Right. There's so many reasons why you can't do this over land, but when you do it,
someone's told me a point that a laser beam divergence is a cone shape before any atmospheric effects.
Yeah.
So, you know, and also the laser emitter on the drone was 0.4 arc seconds in size, smaller than most stars. So, you know, your math doesn't add up either way.
Okay, guys, I don't have what you need for the laser experiment. Can we go on to your proof that Earth moves, please?
Can we go on to our proof of what?
That the Earth moves.
Of Earth.
Okay, well,
wait, no. Let's stop, because I'm fed up of defending the globe, because we've done that. We want you to prove the flat Earth. So
every experiment ever conducted to prove Earth moves has failed and prove it's completely stationary.
No, that's completely wrong.
Every one of them, and I know what you're going to say because I know your arguments. I've seen enough of your videos. Every one of those is dependent upon something that's never been measured or observed. Hey, guys, how familiar are you with the Michelson-Morley experiments? Not the one, but the body of experiments. How familiar are you with those?
Yeah, experiments.
No, well, hold on. How familiar are you with the body of experiments?
I don't claim to be an expert. Guys,
okay.
I'm just wondering. It's 2-on-1. I wanted to talk to one person. Who's going on mute? Who's going on mute?
Okay, I'll let Fight the Flat Earth talk. Go ahead.
Okay, great. So Fight the Flat Earth is going to prove Earth rotates. 1, observe natural phenomenon. What do we got?
Okay, I'm not going to your whatever
All right,
you
well,
think
put Team
scientific
Skeptic
method
back
is.
on. We'll do him.
The proof of the Earth
Go on mute,
rotation.
and I'll talk with Team Skeptic because you don't want to talk about science. I want to talk
No,
about
no,
science.
no, no, no. I don't want to talk about what you think science is. You don't understand the scientific method. We can prove that the Earth rotates in many, many ways. Like, you're going to stop talking when I talk. I mean, for goodness sake, the Echo Star 11 literally did a 24-hour live stream for a long time, proving that the Earth rotates, watching it. You know, that there is every gyroscope that actually measures rotation, measures a 15-degree per hour rotation.
Wait, mechanical gyros?
I'm talking pendulums prove the Earth's rotation. You can set up a pendulum yourself, and actually, with the arc that the pendulum would mark out, you can calculate your distance from the North Pole. There is millions and millions of ways. Stop.
Hey, can we go one point at a time?
Nathan, will you straight?
Yeah, one point at a time. Let's do 1 point. I agree, because you're giving them a lot of information to take in. So name your first point, Fight the Flat Earth, and we'll let Nathan respond to that.
Wait, I already have one. He said every gyroscope, mechanical gyroscopes don't show deviation.
Do you know why?
Inertial-based gyroscopes don't have a gimbal base rotating around the flywheel. So are you going to concede that you lied to your audience?
No, absolutely not. Because if they're accurate enough and they are, there's enough of the resistance taken away, then they do have a deviation. And in fact, I presented recently a homemade mechanical gyro compass that can find you true north by, using the rotation of the Earth and everything. So it absolutely works.
Can I see the time lapse of the mechanical gyro moving around the flywheel? Do you have that video? Pull it up.
I can link you the video of a mechanical gyro compass working. Do you know what a gyro compass is?
Wait. You said every gyroscope has deviation and proves Earth moves.
I said every one that measures it. They have to be accurate enough, and that's why things like. Will you stop talking over me? Because you're extremely frustrating to talk to, and I will go Super Saiyan.
Nathan, let Fight the Flat Earth answer what you just said about the mechanical gyros.
All right. If they are accurate enough, they will measure a rotation. But most mechanical gyroscopes are limited by things like resistance and stuff, which is the reason why things like ring laser gyroscopes and fiber optic gyroscopes were invented, because they are extremely accurate at measuring any movement.
Okay, will you concede that every gyroscope doesn't measure Earth's rotation? You just said
I said every one that measures it, that is able to measure it. Every gyroscope that is able to measure the rotation shows a 15-degree per hour rotation.
But I'm still. Can we?
I'm not okay. Like, if you want me to say, not every gyroscope will show it, because most of them aren't accurate enough, which is my point.
So mechanical gyros, you said, show gimbal base rotating around the flywheel.
Oh my goodness, right? Did you not listen to any of the words I just said?
Do you have that observation?
I can point you to a mechanical gyro compass that shows exactly what you need to see.
A mechanical gyro compass is not an inertial base flywheel with a gimbal base around it. Okay? If you put a gimbal base on a table and watch it for 6 hours, it should rotate just like the ring laser gyroscope, because Earth rotates under the flywheel.
Right, but there's a reason why the ring laser gyroscope works like that. It's because there's no resistance to the light. There's resistance, there's friction, there's all kinds of different variables you have to, for the mechanical gyroscope to be able to measure that. It has to be a very specific type of mechanical gyroscope. It has to be one that has very minimal friction. That's the number one problem that they have.
You guys just took me one. I don't need 1,000 videos. Just show me one mechanical gyro rotating around the flywheel. We got how many people here watching? Do you have one video of a mechanical?
I mean, I don't have it on hand.
I don't know right now, but that is the point.
Just like your experiment, we'll get you that video too. When next time we bring you on, we'll have that video ready for you, and you can see. We'll either get we'll get a sub to make it instead of pulling one off the internet.
But anyway, my point was, that is why we need things like the ring laser gyroscope, because they are a lot more accurate. And you cannot deny the fact that they do measure a 15-degree rotation.
Craig, what I can deny is they're measuring the 15-degree rotation of Earth. You're affirming.
No, you can't, because
Wait,
you don't know how a gyroscope works.
Okay.
It doesn't measure the light around it. It measures what it's on.
I let you talk.
Yeah, no, so now you present a point for your side, since he just presented one for the thing. You may not agree with it, but now you present yours, and he'll refute your point.
Craig's saying, look, the laser deviates 15 degrees. Earth's rotating.
Hey Nathan, I'm saying more make a point for your position on the flat Earth, not an attack on the globe Earth. Your position, your positive position for the flat Earth.
Okay, well, if the gyroscope is recording a 15-degree rotation from the secondary reference point of the gyroscope with the Earth rotating under it, that would necessitate at the equator, because 15 degrees of Earth at the equator would have to be moving 1,000 miles an hour under airplanes and hot air balloons and anything else that's thrown up in the air and leaves the reference point of the Earth and goes into the secondary reference point of the Earth's atmosphere. Is that what we observe?
Sorry, were you talking to me or Team Skepta there?
I thought he was talking to you.
I'm sorry, I wasn't listening.
What did you say, Nathan? I'm sorry. I was letting him. I thought you were talking to fight the flat Earth.
I apologize, Nathan. I lost. Can you just repeat what you were saying there? Because I was actually looking in the chat. I do apologize.
For you and the audience.
Yeah, my bad. I was not paying attention. I was looking at the chat. I'm sorry.
If the ring laser gyroscope is recording a 15-degree rotation of Earth under the ring laser gyroscope, that would necessitate that when an object is in the secondary reference point of the atmosphere, Earth would rotate under hot air balloons, footballs, airplanes,
right. Okay, I see where you're going.
And we don't observe.
Right, no, because the thing is, the Earth is, due to friction, again, the atmosphere is moving with the Earth, and airplanes and stuff fly in the atmosphere that is moving with the Earth, Nathan. That's very, very basic stuff.
Craig, is the gyroscope moving with the atmosphere too?
Well, it's sitting on a physical object.
So it is moving with the atmosphere. So it's funny how,
of course it is.
When you want to have a Coriolis effect, the gyroscope...
Oh, no, you cannot debate the Coriolis effect. There's literal mechanical devices that depend on the Coriolis effect existing. There is military manuals that have tables for adjusting for spin of the Earth. So the Coriolis effect isn't something to be debated. It literally exists and can't be denied.
Hold on, I'm going to post the U.S. Sniper Manual in the chat. So
yeah, lovely. The U.S. Sniper Manual doesn't have it, but the military. Wait, 1 sec. I'll get you the exact.
Wait, a Sniper Manual doesn't have it? Oh my gosh! Okay. Are we backtracking here? This is too funny.
Oh well, it can be funny all you want. However, what does have it? There's actually a couple. The Army Marine Corps artillery manuals start at the 1 kilometer range and have charts for correcting for Earth spin immediately from that range and beyond. Specifically, table H of I'm talking. Don't interrupt. Specifically, table H of Army Manual FM 640, Chapter 7. So there is military manuals that show you how to do that.
But it's not in the Marine Sniper Manual. Why?
I never said that it was.
Oh, okay, but if Marine snipers. If Coriolis is real, Marine snipers should know about it, right, Craig?
I'm sure they do, and in fact, I know someone who is a sniper and actually has talked about that. But I wasn't talking about snipers. I'm talking about the fact that there is a military manual that actually has tables for correcting for the spin of the Earth. Whether it's for a sniper or not isn't the issue here. I'm not a sniper. And I've never read a sniper's manual, but I know specifically there is military manuals that have charts for correcting for the spin of the Earth. More than one, actually. So, and also, do you know what a mass flow meter is, Nathan? Nathan, do you know what a mass flow meter is? Nathan, you're muted for some reason.
I didn't mute him. I wasn't on the screen.
I think you muted yourself by accident. No one's muted you here. You need to unmute yourself.
There might be something going on. We'll give him a second to unmute himself. Yeah, I was interested in this the mass flow meter that you were talking about the other day. I didn't even really look into it, but yeah, he just dropped. We'll give Nathan a chance to come back.
Yeah.
Yeah, I didn't look into it, but I really want to see how that works right there.
Oh, hey, Nathan.
Sorry.
No problem. Okay,
yeah, so Nathan, do you know what a mass flow meter is?
A mass flow meter?
Yeah.
No, I've never heard of it.
Right, a mass flow meter is a mechanical device that is designed to use the Coriolis effect to create vibrations and is extremely accurate at measuring both the mass flow and density of fluids. It is utilized all over the world in engineering, in drilling for oil, for checking for levels, for maintaining certain systems on ships. Yeah, it literally uses vibrations created from the Coriolis effect to measure mass flow and density of fluids. That's literally what they're designed to do. They wouldn't work if the Coriolis effect wasn't a thing.
That's great, Craig, but the Earth doesn't rotate under airplanes or hot air balloons or
That's because the atmosphere is moving with the Earth, Nathan. We literally just went over that.
That object that you're using, the mass, whatever you said, is that in Earth's atmosphere?
Yes.
Gyroscope, is it in Earth's atmosphere? The gyroscope, the Foucault pendulum, is that in Earth's atmosphere?
That's really a ring laser gyro in Earth's atmosphere.
That's not the point.
No, it's not. The ring laser gyro. No, the ring laser gyro is a sealed vacuum tube.
Everything is in Earth's atmosphere.
I'm almost positive. No. You're wrong there.
Okay, so you're telling me that the gyroscope is in space?
No. I'm telling you that the mechanism that measures. Hold on, listen. The mechanism that measures the 15-degree drift is completely separate from the outside atmosphere. This is 100% accurate right here. You're not bouncing light in the atmosphere trying to determine how fast.
Nathan, if I could just clarify your question about the sniper's manual. The sniper manual actually stops at 1 kilometer. Artillery manuals start at 1 kilometer, and that's when correcting for the Earth's spin comes into play. So no, a sniper manual which only goes up to 1 kilometer would not have charts for correcting for the spin of the Earth.
Well,
and that's just semantics.
You're claiming distance, all that.
Go ahead. I'm sorry.
And airplanes don't adjust for Coriolis.
Well, but like the thing about the Coriolis is that it's most likely to show an effect when there's no other forces acting on it. Wait, stop interrupting me. I'm talking. All right. When you're in an airplane and you're flying, you have a lot of other forces coming into factor, the thrust of the plane, the drag of the air and everything. So they are much more prevalent than the Coriolis force. So no, you don't really need to take the Coriolis force into account when you're flying a plane.
When I said hot air balloons and airplanes and all that stuff, you said that's in Earth's atmosphere, right?
Yes.
Okay, when you fire an artillery, is that in Earth's atmosphere, Craig?
Yes.
Okay, do you know?
That doesn't mean that it cannot be affected by the Coriolis force.
I'll just let you keep doing this.
Team, do you want to? I'm pretty sure I've just destroyed him there. Do you want to take that bit?
I don't want to jump in until Nathan would like you to stop and me to get in.
Oh,
Nathan. I see his point. I don't want to tag team on him. I want him to feel like this is a fair discussion. So we'll keep doing one person at a time. Go ahead, fight the flat Earth, but go ahead.
Yeah, go ahead, fight the flat Earth.
Well, again, like I was saying, the everything else, planes, hot air balloons, whatever are flying, they all have other forces acting on them, and they are not a bullet or an artillery shell or something that is literally moving through the atmosphere. The atmosphere is moving with the Earth because of friction. Obviously, that's going to have a lot of effects on the artillery shell, but the mere fact that it is now in its own inertial reference frame, it will still be slightly affected by the Coriolis force.
When you say the atmosphere moves with Earth, what you're saying is there is no Coriolis.
No, we're not, because that's not what the Coriolis force is. Don't misrepresent our model and don't put words in my mouth, because neither of those things are anything that anyone has ever said.
The Coriolis states when you're at the second reference point in the air, Earth rotates under you. Is that what Coriolis is? Do we need to read the definition off the internet?
No, okay.
No, we all know what the Coriolis force is. It's an apparent force that acts on something that enters an inertial reference frame. We all know what the Coriolis force is, and we all know that there is so many variables and factors that come into play.
Well, the number one thing we all have to do, Nathan, do you at least accept that conservation of momentum is a thing?
Is Craig going on mute now? Is it Team Skeptic's turn?
No, go ahead. I just want to know if you believe in conservation of momentum. No, I won't. I'll let him.
That's where I was going with my question.
Oh, no. I'm not trying to take notes. I don't need to take notes about this because I've done a video on it. But you're right. I'm not trying to step in.
Just shut up.
Hey man, listen, hold on. Hold on, Nathan. I've been very fucking polite to you without cussing the entire time until just now. Don't tell me to fucking shut up, and I'll continue to not cussing. Yeah, I know, and then I stopped and said, yeah, you're right. I just asked you a question. Do you accept that conservation of momentum is a thing? I realize I overstepped my bounds. I'll let Craig go back to it, but don't tell me to fucking shut up. And I'll continue to have this. Yes, you fucking did. You said shut up.
Guys.
No, you just said the F word. I didn't say that. I didn't tell you.
Yeah, and he's apologized.
You said Team Skeptic, shut up. We'll go back and play this later, but you said that shit.
I know, but you just said I told you to effing shut up.
No, I said I haven't cussed until now when I said don't tell me to fucking shut up. Okay?
Yeah, okay.
All right. Be polite, and I'll reciprocate.
I thought we weren't cursing.
I wasn't going to curse until you told me to shut up.
Can I just say, frankly, I don't have an issue with cursing. I think it's an excellent way.
Okay, that's fine. That's fine. Just don't tell me to shut up, and I'll continue to be as polite as I'm being up till this point.
You've been interrupting the whole time. That's not very
polite.
Right,
okay, let's stop. Nathan, we're going around in circles here. Let's get back to the point of you not understanding the Coriolis force.
Let's get back to a one-on-one conversation with everyone else on mute.
Well, hey, hold on. Let me just put something on. I'm going to let you guys talk. I have to go run and pick my kid up from work right down the street. I'm going to leave the live stream up. You and Craig will have y'all's conversation. Please keep it civil. Craig, please, Fight the Flat Earth, please keep it civil.
Okay, I promise.
Nathan's been nothing more than civil so far, so I don't see any reason why he's going to change that as long as you stay civil with him. So please do so, and I will be back shortly. Thank you, guys. Hey, everybody that's left a super chat, we are going to address all the super chats at the end. Nathan, please don't leave until I get back. I'll be back in 20 minutes. All right?
Yep.
Okay. Right. So the question that Team asked is actually one that I was going to ask. Do you believe and understand what the conservation of momentum is?
You don't have to believe in science, Craig.
I know. I would try. Okay, wrong word. I'm more trying to say, is the conservation of momentum something that you ascribe to?
Can you explain the?
No, answer my question. Don't just answer my question.
I want you to define conservation of momentum so I can agree on it or not. Okay, go ahead.
Tau equals L over T. Well, that's a conservation of angular momentum.
Don't give me the formula. Explain to me what it is, Craig.
An object in motion will stay in motion unless there's other things acting on it, basically. And
okay,
when you
I'll agree with that. Let's go.
That's the angular momentum. So if you want to argue about semantics or not, I just want to know, is the conservation of momentum something that you subscribe to?
Yeah, that's a real thing.
Okay, so then can you also tell me what the difference between a bullet and an aircraft is?
Okay. An aircraft is in the atmosphere. A bullet is in the atmosphere. Now, the Coriolis effect.
Okay, right. This,
are you going to interrupt me, or can I talk?
Well, no, you've missed my point there. The difference between a bullet and an aircraft is that one is powered and the other is ballistic.
Okay. Well, when a balloon is in the air, is it powered?
Yes, it is. That's why you have someone operating the big fiery.
I didn't say a hot air balloon, Craig. I said a balloon.
Okay. Nathan, if you talk to me like that again, I will get quite angry. All right? Show some respect and you will be given it. Is that clear?
I'm being clear with what I'm saying.
No, you're being very disrespectful, okay? And I will be respectful to you if you are respectful to me. That is the first warning. Don't make me ask again. All right.
I said a balloon. You assumed hot air balloon.
Yes, and you could have corrected me without sounding like a 5-year-old.
I did. Okay, so I didn't mean hot air balloon. I said balloon. So
okay, and you could have said
balloon,
that.
Craig, when you release a balloon, Craig, at the equator, is Earth rotating under the balloon?
Again, watch your tone.
Dude, I'm having so much fun. I hope.
Oh yeah, I'm loving this very much so.
Yes.
And
no cursing and no insults, Craig. Yourself. Try to contain yourself.
Oh, I'd love to break out, but Teams asked me to be very nice, and this is on his channel, so I will abide by his wishes.
Excellent.
So the balloon that is just floating about, there's again many factors acting on that balloon. It's not just the Coriolis.
Oh, so there is Coriolis affecting on the balloon. So guys,
Coriolis affecting everything. Coriolis is an apparent force that affects everything to some degree.
Okay, guys, listen to what Craig is saying. When you release a balloon, the Earth's going to rotate under the balloon. That's what Craig's saying to you guys. So
no, I'm saying that the balloon's in the atmosphere, but there will be effects from the Coriolis, the same as a bullet or something that is ballistic. But again, you have to take in all the other accounts, all the other forces into account. Yeah. So you're ascribing this all or nothing kind of mantra to it, and that's not how it works.
No. You're saying Earth moves under it, and I'm saying no, it doesn't. And you're like, yeah. There's other forces. And I'm saying
that the balloon will be mostly affected by the atmosphere that is moving in, but there's no other forces to be taken into account, like an airplane or something that has thrust being created by the engine.
So, guys, listen very carefully what Craig is saying. When an object is propelling, there's no Coriolis. The Earth doesn't rotate under the object.
No, I didn't say there's no Coriolis. Let's get it clear. I didn't say there's no Coriolis. I never said that at all. Coriolis is always going to be having an influence on things. But when you're in things like aircraft, there is much bigger forces in play. That the Coriolis effect is negligible.
It's negligible.
Now, yes. However, Nathan, the fact is that we cannot deny the Coriolis force is a thing, because again, there is actual bits of mechanical equipment designed to use the Coriolis force.
Craig,
you understand that?
Science is natural observed phenomena.
No, do you understand that something literally wouldn't work without the Coriolis force?
When you say my scientific proof are these man-made devices, you don't know what natural science.
Well, Nathan, again, we're not going to get bogged down in what you think science is, because your little group of numpties on the internet are very bad at actually describing what science is.
Not what I think science is.
You know, it is what you think science is, and you know, I'm going to share my screen here so people can see what I'm talking about.
Method.
No, Nathan, I've backed you into a corner talking about something that requires the Coriolis force, and you're just going to go off arguing about the scientific method. No, that's not how it's working.
No.
Yes. Now be quiet and look. All right.
Man-made devices
to
try and
no, Nathan, that's not going to fly. All right. This here proves the Coriolis force is a thing. This would not work without the Coriolis force. Okay? You cannot deny something that physically affects other things. The mechanics of this would not operate without the Coriolis force being a thing. Okay? Stop denying something that is right in front of you, please.
Earth doesn't rotate under anything that leaves Earth's surface. So
Nathan, I'd like you to debunk a mass flow meter. Nathan, right?
Guys,
my proof of the Coriolis force is a mass flow meter. Can you please debunk it?
I've never researched the mass flow meter. Would you like
what it says in front of you? Read what it says in front of you.
I can't read it. It's too small on my screen.
Get a proper computer.
I'm on my phone. My computer, I was just live with Paul on the plane for 2 hours. It's dead. Sorry, Craig. And you guys called me out.
I can read it for you.
You guys called me out.
Right, listen, Nathan, I'll read it for you. A mass flow meter. Nathan, a mass flow meter, also known as an inertial flow meter, is a device that measures mass flow rate of fluid traveling through a tube. The mass flow rate is the mass of the fluid traveling past a fixed point per unit time. The mass flow meter does not measure the volume per unit passing through the device. It measures the mass unit per time. The volumetric flow rate is the mass flow rate divided by the fluid density. If the density is constant, then the relationship is simple. If the fluid has varying densities, then the relationship is not simple. The density of the fluid may change with temperature, pressure, or composition, for example. The fluid may also be a combination of phases, such as fluid with extended bubbles. Actual density can be determined due to dependency of sound velocity on the controlled liquid concentration. There are two basic configurations of Coriolis flow meter: the curved tubed flow meter and the straight tube flow meter. All right. Now, there's a whole thing here that goes into explaining how they use the Coriolis force to measure the mass flow and density of a fluid, and they are extremely accurate. These things, literal physical devices, would not work if the Coriolis force was not a thing. Okay, it's as simple as that.
So on Craig's side, he's got ring laser gyroscopes, Foucault pendulum, and this thing. And I've got airplanes, hot air balloons, insects, footballs, baseballs, anything else you throw in the air does not have a Coriolis. So, all right, Craig.
Nathan, there is no point I've said that. So you can keep misquoting me and putting words in my mouth all you want. Whereas I can just present you evidence after evidence of the Coriolis force existing.
Guys, this is not that hard to test yourself. You don't have to believe what Craig is saying on the
No, I'm not asking people to believe.
Hey, don't interrupt me.
Clear. Science doesn't have beliefs. Science doesn't give a shit about your beliefs.
I let you talk. Okay?
Yeah, but I'm not going to let you misquote me. All right? Let's get that clear. If you try to misquote me, I will interrupt you and stop that happening.
Okay, guys. Earth rotates under everything. Balloons, airplanes, not sniper bullets because it's not in the manual, but artillery bullets because those travel far enough. I mean, dude, you're not seeing all the double speak in your argument?
Oh, no, I'm not presenting any double speak. I'm presenting evidence after evidence of the Coriolis force existing.
No, you're not.
I am. I can do it all day.
Observed natural phenomenon.
Nathan, we're not getting bogged down in what you think the scientific method is. We're not doing that here, okay? Because you're wrong, and everybody knows that you're wrong. Everybody knows that this stupid version of the scientific method that's come from quantum erasure is a whole load of rubbish. So stop arguing what you think science is and actually respond to evidence that's presented to you rather than just going on a rant like a 5-year-old child.
So just so we're clear, Craig does not think science is observe natural phenomenon, can actually form a hypothesis, then do rigorous experimentation.
You do know that the scientific method does not have to be applied specifically in that order, or even to have all those things in it. That is not how the scientific method works. No, it doesn't. Go and Google the scientific method, Nathan. Just for once, do a little bit of research.
As I told you, you guys called me out while I was live in a 2-hour video with Paul on the plane. My laptop is dead. So if you want to Google, go ahead. You got the computer.
Okay, so right. So yeah. You go into and actually read about the scientific method. One of the first things it says when you go into Wikipedia and actually read about the scientific method and the way it's developed is that it does not, you don't use all those things in that specific order. You don't have to use every bit.
Are you going to read it?
Sorry, one sec. My tabs are closing. Bear with me. I'm trying to find the right bit to read out.
So just so we're clear, the audience, Craig is saying you don't need an observed natural phenomenon.
No, I'm not. Stop putting words in my mouth, Nathan. I never said that. All right.
Well, what's the observed natural phenomenon for Coriolis then?
Right. We're not getting bogged down in what you think the scientific method is. Okay. We talked about that.
So we're not getting bogged down in what the scientific method is. You want to take a man-made device and declare that's affirming the consequence.
No, again, right. Stop making a fallacy. Yeah. That doesn't work.
Yeah.
I am presenting evidence.
You're saying the light deviates, so Earth rotates. If P, then Q. P happens, so Q. That's exactly what affirming the consequence is. You're saying the Foucault deviates a little bit, so Earth's rotating. Look, guys, the Foucault's moving. If P, then Q. P, then Q. That's not
again. This all come. You literally sound like Nathan Oakley at the moment. You're just spouting all his normal nonsense fallacy distance. You can say fallacy, fallacy, fallacy all you want, but I can literally point out the points where you're wrong. So
reuse the fallacy again.
I don't need to use the fallacy because I can point out points that you're wrong about. Okay.
If P, then Q.
No.
Q happens, so P.
No.
If we see a deviation in the ring laser gyroscope,
no,
light,
Nathan, stop talking rubbish, right? We present evidence, and we let evidence lead us to conclusions.
Yes, evidence. So, one, observe natural phenomenon. What is it? The Earth's moving. How come only things that detect Earth's moving are your man-made devices that are conjured within the experiment or within the device?
In nature to allow you to observe to actually measure the Earth's rotation. You realize that we develop tools for a reason.
Earth's moving 15 degrees an hour. That's 1,000 miles an hour. So what do you need all these fancy devices for?
Because there isn't anything that measures. Right, Nathan, you're just talking nonsense right now. You're literally just saying, oh, you're not allowed to use tools to measure something. Don't be ridiculous.
No.
Yeah.
Measuring things is not the scientific method. It's a measurement.
Okay. What I presented to you was an evidence. It wasn't like proof of anything. It is just one thing and as evidence. Okay.
Proof of anything. Exactly.
I didn't say it was. I said it was evidence of the Coriolis force. Right. It shows that the Coriolis force is a thing because this leads to the Coriolis force to operate. So instead of arguing semantics, actually come and rebut the science of what I'm presenting you.
You didn't present science. You presented a fallacious argument called.
I presented you evidence of the Coriolis force.
Affirming the consequence. You're saying deviation in the mass.
About fallacies. This isn't going anywhere if you're just going to keep trying to change the subject. I am asking you to actually refute the evidence that I presented you, that the Coriolis force is a real thing.
And I'm saying you're affirming the consequence.
I'm ignoring that, and I'm going to ask you to answer the question and refute the evidence that I presented you. I'm not affirming any consequence. I am letting evidence lead me to conclusion. And when I find all the evidence leads me to one conclusion, that is the conclusion that I will take. That is not affirming the consequence. Stop being silly and actually answer the question, Nathan. How does a mass flow meter not use the Coriolis force?
Could you give me an observed natural phenomenon?
Nathan, that's not what I asked. Are you going to answer the question? Or are you just going to keep spouting nonsense? Nathan,
your man-made device that I've never used.
Nathan, can you answer a question? This is getting silly. I need you to answer a question. All right?
I've never used one. I don't know how they work. Can you show me a natural phenomenon?
I'm showing you a mass flow meter.
I've never used one. Can you show me a natural phenomenon?
I'm showing you a mass flow meter. I'm showing you.
In nature, show me your mass flow meter.
Why is their manuals correct for the Coriolis force?
Wow, a man wrote a manual, and he told me it corrects.
So basically, you're using genetic fallacy. That's fantastic. Well done.
Wow, a man wrote a manual, guys.
Do you see how? I hope everyone watching see how much this guy is squirming. When I ask him to answer a question directly, he can't do it. When I ask him to refute something, he can't do it. I hope everyone is enjoying this because I am. I'm really trying to not like blow my lid at how arrogant and rude he is, but it's fantastic that I'm embarrassing him so much.
You're looking at a man-made device with no natural phenomenon and claiming
the Coriolis force is a natural phenomenon.
You're saying if P then Q.
No, I'm not.
P then Q.
No, I'm not.
Yeah, you are.
No, I'm not.
What you're doing.
Nathan, we're not going to argue about your semantics of what you think fallacies are. All right. How about you now? Right. I've presented evidence like my evidence, and you haven't been able to refute it. So let's move on. And you now present me some evidence for the flat Earth.
That wasn't evidence.
Well, you can say it wasn't evidence all you want, but I'm going to disagree with you and say that we move on for the sake of this conversation because
Dude,
I would now like you to present some evidence of flat Earth.
Has a 15-degree deviation. So
right, Nathan, are you able to have a conversation? Right, listen to the words coming out of my mouth. Nathan, shh. Listen to the words that I'm saying. It is now your turn to present some evidence. Please go ahead and present me some evidence for the flat Earth.
Yes, I will. You can't have gas pressure without a container.
Okay, now please describe to me the zeroth, the first, second, and third law of thermodynamics.
First law of thermodynamics.
No. The zeroth, the first.
I don't know the zero.
Oh, right. Okay. So you're trying to quote thermodynamics when you don't even know all the laws. Fantastic. Please carry on.
I know the second law is high pressure systems move to low pressure systems.
That's not what the second law of thermodynamics is.
Oh, okay. Well, then tell me what the second law of thermodynamics is with the audience.
No. Sorry, you've used the trying to use the law of thermodynamics as proof. So you need to prove what you're saying. Okay. I know, and so does everyone else know what the law of thermodynamics is.
You told me I was wrong. Are you going to tell me how I'm wrong? Or are you going
to let me finish? I'm still waiting for you to tell me all of the laws of thermodynamics, because you can't just use bits and bobs. You need to use all of it.
Wait. You asked me for proof of flat Earth. I start giving you a proof, and you're like, "Tell me."
Yeah, but the second law of thermodynamics doesn't prove flat Earth; it disproves it.
You're telling me I have to now tell you all 4 laws of thermodynamics to give you.
If you're going to try and use thermodynamics, you need to show me that you understand it, because I did an entire bloody period of studying thermodynamics during my physics degree. So, if you want to talk to me about thermodynamics, I need to know that you have at least a base understanding of what you're talking about. So that means that you need to describe to me all of the laws of thermodynamics and how they apply to the flat Earth, because not only does the second law of thermodynamics completely destroy flat Earth, so do the other 3. Carry on, and please tell me now how the second law of thermodynamics can, back up flat Earth.
Yes. The entropy of an isolated system consisting of 2 regions of space, isolated one from another, each in thermodynamic equilibrium in itself, but not in equilibrium with each other, will, when the isolation that separates the 2 regions is broken, so that the 2 regions become able to exchange matter or energy, tend to increase over time, approaching a maximum value when the jointly communicated system reaches thermodynamic equilibrium.
And so how does that apply to the flat Earth?
So I have an MIT professor saying, if you have gas pressure next to a vacuum, the gas fills the space. Wiggles 2018.
Okay, so now
show me.
Let me ask you: is the Earth a closed system?
Yes, it's a closed system.
No, the Earth is 100% not an isolated system, because we receive all our energy from outside of the Earth.
On your model, you believe. Okay,
no, I don't believe anything. I don't believe anything, Nathan. I have a model that is verified by reality. You don't even have a model, so.
Okay, got you, Craig. Well, you just walked into a huge trap. If it's not a closed
no, I'm still waiting for you to explain how the second law of thermodynamics applies to flat Earth, because it doesn't.
I'm still on that point, Craig. So just hold on. Stop talking for 2 seconds. I'll tell you. You said it's not a closed system. It's an open system. So if you have a 10 to the negative 17 torr vacuum of space next to...
Do you think there's such thing as negative torr?
Next, I've never witnessed it, but that's allegedly what space is.
Right. Can you tell me what torr is?
It's a unit of measurement.
Yeah, based on what?
Based on the vacuum of space.
No, it's based on an absolute scale. So you have 0 torr, and that you don't have negative torr.
It's negative pressure, though, right, Craig?
No.
So a vacuum isn't a negative pressure system? It's a positive pressure system?
Goodness me. Guys, you enjoying this? This is fantastic. I'm still waiting for you to let me know how it applies, because it doesn't.
You keep interrupting me.
Well, I just need you to clarify terms, because you don't understand the things you're talking about.
If you have gas pressure next to a vacuum, the gas fills the space. Wiggles 2018.
Okay, so
gas pressure.
Is there another force acting on anything, Nathan?
I'll give you gravity. You can have gravity.
Thank you.
Gravity.
Well, if you've given me gravity, you've just concluded that there is no flat Earth, because a flat Earth cannot exist if there's gravity. Well done. Guys, you heard it here. Nathan Thompson is no longer a flat Earther. Nathan Thompson is no longer a flat Earther.
Dude, you're such a joke. I said for this one observation, you can have gravity.
No, you can't give me gravity for one observation and not for another, Nathan. That's not how it works.
Okay.
Well, can you just show me any gas pressure resting next to a vacuum or a negative pressure system without a container? Using gravity or without gravity, I don't care. It's up to you.
So you want me to show you two separate pressure systems next to each other without a container?
No, a positive pressure system and a negative pressure system.
So basically, you want me to show you two different pressure systems. That's all we're saying here is that there's a difference in pressure, right? That's the thing, Nathan.
No,
saying positive and negative pressure, right? What we're talking about is something at a lower pressure to something else. That's what you're talking about, and I can show you that wazoo.
That's not what I'm talking about. I'm saying, can you show me gas pressure without a container, Craig?
Yes.
Okay.
Do you know what a storm system is? There's gas pressure without a container. Do you know how an aircraft creates lift with its wings? By creating a different gas pressure. So, there you go.
All that gas pressure is contained, Craig. That's why it has pressure. If you take away the molecules within the
when's the gas
Craig,
pressure contained around the wing?
You can interrupt me every time I talk.
You get things wrong. There is no such thing as negative pressure, Nathan. This is hilarious.
Wait, say that one more time. I didn't hear you.
Keep going.
Wait, what'd you say? There's no such what? What'd you say, Craig, right there?
Well, there is no, you don't have negative pressure systems. You have differences in pressure. Pressure is defined as the force per unit area.
Did you just say there's no such thing as a negative pressure system, Craig? Did you just say that? In front of your whole audience?
There is zero pressure, Nathan.
Audience? You just told all the globe heads there's no such thing as a negative pressure system? Oh my gosh! Wow, I'm going to save this and put it on my channel. Thank you so much, Craig. You're right. There is no negative pressure system. Space is fake. They've been making it all up. That's why NASA's caught using green screen, harnesses, augmented reality, hairspray, the vomit comet. It's all fake. It's all fake, Craig. And your reality's crumbling.
But do you want to tell me how negative pressure exists?
I never claimed it exists, Craig.
No.
Well, you can create a
what a negative pressure system is, because there isn't negative pressure in space. There's zero pressure.
Wow. Wait. So it's just zero pressure. It's not negative 10 to the negative 17 torr, Craig?
Right. 10 to the negative 17 torr, whatever you're, does not mean negative pressure, because you don't have negative torr. Okay, the pressure in space is practically 0 psi. You don't have negative psi.
That's what a vacuum is, negative pressure.
No, it's not. It's a lack of pressure. It's 0 psi.
No. A less pressure system would be lack of pressure. A negative pressure system would be the opposite of low pressure.
So are you telling me that you can go below 0 psi?
What was that?
Are you telling me you can go below 0 psi?
Yeah, Craig. It's called a vacuum chamber. NASA seduced.
Right, wait. So you think vacuum chambers go below 0 psi? I just want you to clarify that you think that there is such a thing as below 0 psi. Can you say that once more, just so everyone can hear it?
It's a negative pressure system.
Right.
So
you do know that 10 to the negative 17 is actually a positive number, right? I'm getting confused as to what you actually understand and don't here, because
it's a positive number relating to the negative pressure system.
Right. 0 psi. You don't have below 0 psi, Nathan. A vacuum is 0 psi.
All right, I'm back, guys.
Here, Team Skeptic. He thinks you can have negative pressure. He thinks there's something below 0 psi.
No. You can't have negative pressure. What you have is you have a difference in potential of pressures. Okay, space is not negative pressure. Negative pressure would mean that you had a sucking force. Okay, that you actually you can.
So a vacuum isn't a sucking force?
No, absolutely fucking not. Absolutely fucking not.
Team, I want to make a new T-shirt that's space is negative pressure with Nathan Thompson's face. That'd be brilliant.
No, it's not. It's not. It's a difference in it's a difference in potentials. Okay, and yes, there you have the force of gravity pushing down, and you have the force of buoyancy pushing up, basically. All right, so you have two different pressures there pushing up and down.
Buoyancy is the force.
Yes.
That's what you guys are saying.
Are you not? Are you fucking kidding me? Do you not understand the buoyant force? The buoyant force. No.
Okay.
Buoyancy pushes in all directions. Okay. It pushes down. It pushes up.
But the thing is, buoyancy needs a vector to work, and because the vector of gravity is pulling everything else down, the buoyant force acts in the opposite direction.
I'm glad we got here with Team Skeptic. Craig, shut up. I'm talking to
You don't tell me to shut up, little man.
I'm going to talk to Team Skeptic now. Team, you asked me to wait for you.
Yeah. I'm here. I'm here.
Telling me to shut up first.
Yeah, do you want to talk to me or not, Team Skeptic?
Yeah, just don't. Hey, look. Okay. Look, just don't tell people to shut up. I would appreciate it if you didn't tell people to shut up, because Craig's been pretty. I've done a lot of shows with Craig, and he cusses a lot, and he's holding back a lot of cussing, and I appreciate you doing that. So please just don't tell people to fucking shut up on my channel. Unless they're being overly aggressive towards you, then you have all the right to defend yourself. Okay.
I just want to point out.
When I say that, when I'm saying you said shut up, I'm throwing the adjective in of fucking.
I know, and you agreed not to curse at the beginning of the show.
Okay, fine, okay. So, yes, vacuums do not suck. That is an absolute problem for flat earthers, because you think.
Why do astronauts wear spacesuits?
Because the atmosphere that's inside of the spacesuit wants to escape out to where the higher potential of the equilibrium of pressure. Okay, it wants to. Okay, hold on. I'm trying to explain this in a way you can understand it. Okay, it wants to go away from this. It wants to expand because of its desire to push away from everything else. Okay, the atmosphere that's inside of the suit. All right, but once it gets out there, let's say you were in a confined space, and that was your vacuum, it would equalize out into that vacuum. There would still be a pressure inside of that vacuum. The same thing happens in space. There is a pressure in space, but space is not sucking. It's not sucking the vacuum or sucking the atmosphere out. What's happening is the atmosphere is pushing away from each other in all directions, and you can absolutely see this. This is why the vacuum of space has a small amount of pressure inside of it. It's called vacuum pressure.
The Sandusky Research Center that NASA has is a vacuum center, right?
Uh-huh. Yes.
Okay. Normally, before they turn it on, it has air, right?
Mm-hmm.
Then they take the air out. How do they take it out, Team Skeptic? Do they suck it out?
Yes,
Yeah.
You can pull the air out of that.
Vacuum.
No, but hold on. No, but you're kind of misunderstanding. Are you sure they're sucking the air out, or are they pressing the air out?
How do you press the air out from inside the vacuum? They're sucking it out. Yes.
Okay. Yeah. Okay. So yeah, you'd be right in that. You could press out something if you had 2 volumes of liquid. I'm not sure. I don't know the operation of that thing, so I will tell you that I'm not sure about that. I can look into it, but either way they go, if they're pulling it out, that's just something that's man-made that's pulling the atmosphere out. But guess what? That atmosphere is still trying to go back into the vacuum. It wants to. You have to have like some kind of compressed unit to compress that air into another space. There's no other way around it. It's the same way subs work.
Oh, so if you had the vacuum on inside the Sandusky Research Center, and remove the walls, do you still have a vacuum?
No, if you remove the walls, if you remove the walls, the atmosphere from around would rush in, and it would create an equilibrium throughout the inside of the other container, whatever's containing the. I'm sorry? Okay, so, all right. Okay, great, Nathan. I'm glad we can agree on that. Now, why then do we see a pressure gradient from top to bottom? We don't see it leveled out like you do in a density column. We see a pressure gradient from top to bottom. Why is that the case? If the Earth is contained in a container, why do we not get a equilibrium of pressure everywhere like you're saying right now?
Well,
that should happen, right? You said it should happen, right?
Let me talk, buddy.
Okay, go ahead. Go ahead.
So, there's lots of different elements in the air. The periodic table is separated by density of elements.
hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur.
Oh God, please make him stop.
Titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium. So, Team Skeptic, would you agree hydrogen is lighter than oxygen?
Yeah, of course.
Okay, so that's why it separates out.
But lighter denotes weight. Weight denotes a force. What are you talking about? How can you have a lighter substance if you don't have a force that makes it light?
Can I make one small correction to Nathan about the periodic table of elements? It's not the density of the objects; it's actually the electron shells that determine where they are in the periodic table of elements.
Yeah. Let me talk to him.
I waited to talk to Team.
No, that's fine. That's fine. That's fine. I'm here.
Get
Let's go.
Greg. Okay.
Let's go. Come
Fight
on,
me, little man.
Let's go. Let's go.
So, Team, you agree hydrogen weighs less than oxygen. Now, hear me out real quick, Team, because you've been super cool tonight. I didn't even know you were capable of being this cool.
Yeah, most flat earthers don't, because they see my content. They're like, I don't talk to that guy. Fuck that. This is on live. On live, I treat you guys with respect. So.
And just nasty, bro.
Okay,
Tonight
well,
you've been.
All right, so let's keep going. Let's keep going. Thank you for complimenting me. I appreciate it, but let's keep going.
For sure. So, the elements separate out, but they're always within a container. Similar to how when you use a spray can to go tag up art on a wall, you shake it up because the density level within the container is separated out. Same thing happens with our atmosphere. But what you can't show me, Team Skeptic, is gas pressure without a container. You can talk about a gradient all day long, but you can't show me gas pressure without a container. Now, here's what's interesting. You don't get a container out of nothing. So, second law of thermodynamics proves there's a creator.
Okay, no, it doesn't. No, it doesn't. That's you trying to link. That's you trying to link two things that are completely unrelated. Okay. Hold on one second. Hold on one second. No. Jim, I'm sorry. How did you get the link, by the way?
It was given to me. Am I not supposed to be here?
Oh, well, no, I just didn't know that you were invited. Who sent you the link?
JM has a master's in science.
Okay, no. I know. It's a new person coming in, and I'm actually having to close this down here in a second. So.
Okay.
You're a bit loud. Can you turn your mic down just a bit, Jim?
Sure, absolutely. And it's Joshua Michael. I prefer to go by, but just so you know.
I'm sorry. I thought it said Jim. Joshua Michael. Okay.
It says Jam Truth. Jam Truth is my website name. No. Was it still loud? Is that better?
A little higher, dude. A little higher. But he's got a master's in science. You guys are being super cool tonight. Let's get to the bottom of this. I'm not the smartest flat earther. I'm just the most passionate.
Well, hold on a minute. If he's shutting down his channel, like, I'd rather be here, hopefully, when we can all be civil and go through the science together.
JM, can I just ask that? Are you here, Nathan? Did you invite him in? Because if you did, what we're gonna do is I'm gonna have to shut this down here real shortly. So I'd like to maybe set up a scheduled time when we can bring y'all both back on. If this is somebody that you invited on, if not, JM, we can always figure out a way to bring you on in the future as well.
Yeah.
Hey, I didn't know you were capable of doing cordial talks. We're going to do it in the future with JM. JM, hang out though a second, because I want to bring something up, team. You said, when I brought up the inverse square law, you said, go 100 freaking miles up, and it's not that big of a difference compared to the size of Earth. Do you remember when you said that?
Yeah, absolutely.
Okay, so if you go 100 miles up and there's not that big of a difference with gravity, how come you go 170 miles more and you float in the ISS?
They're also experiencing a 9.8 meters. Well, it's a little bit less at that point, but it's probably more like 9.
I think it's about 8.8.
It's 8.8. Okay. Without doing the math, I don't know it without the math, but it doesn't matter. Everything is falling at the same rate, but it's also got a tangential velocity that carries it around the curve. Okay, as long as the tangential velocity is calculated out right, and they can get it to where it forms at least a somewhat circular orbit, then they don't ever have to change it until they have the minor fluctuations from the minor atmospheric drag that they experience. But for the most part, they are falling, but they're all falling together.
Okay, but team, if gravity is keeping the orbit of the ISS, why is everyone in the ISS experiencing zero gravity?
Because they're traveling with the ISS as well.
Gravity. They're only in free fall. They're only. This is back to the example I was trying to give you on the show when I was saying a density column in free fall. It loses all of its density or its buoyancy properties. Density column. Same thing happens on the ISS in a frame of in a reference frame. In that reference frame where it's the space station and the astronaut, they appear to be free floating inside to each other, but not out in an external reference frame. In an external reference frame, they're all falling together. It's simply a matter of everything moving at the same rate in the same direction. But when you're inside, you feel like you're floating around because you're right there on the inside of it, and it's. Go ahead.
Okay. Are we gonna be on long enough that I can actually make a comment to that?
Go say something, JM. Go for it.
Yeah. Go ahead.
It's okay. All right.
I've got about 10 minutes, and I got to read super chat. So.
Okay. All right. Cool. First of all, as far as I'm concerned, I would prefer things to stay cordial, no name calling, blah blah blah. I don't.
Yeah, we're there.
I consider myself a professional, so I don't want to fight about stuff.
No, I understand. We're here to have a discussion. It's a science or satire. The name of my show is Science or Satire. We have a good time discussing science.
Right. Okay. Cool. What you just explained makes no sense from a spatial reference point. What do I mean by that? The people inside the ISS, you said, are moving at the same velocity, obviously, as the ISS is moving. Mm-hmm. However, the ISS, what you've just said, is that the ISS is affected by forces that the people inside the ISS are not affected by. That cannot be.
No, I'm saying they're all affected by the same force. They're all experiencing the same relative motion. They're all in the same inertial reference frame.
So you're all right, but your position is that the inertia of the ISS is keeping it up, or that they're in constant state of free fall?
They're in a constant state of free fall.
Okay, so centrifugal force has no effect on that ISS, correct?
Yes, has no effect.
Okay. Will you concede that centrifugal force is even a force?
Well, when you say, will I concede that, you have to actually state your position for me to concede. Are you saying that centrifugal force is not an actual force? Or
no, I'm saying it is. It absolutely, it is a force because we use it to calculate things all the time.
Well, we can calculate it, but it is a fictitious force. Yes.
Oh, okay. So it.
How do you calculate a fictitious?
How do you calculate something that doesn't exist?
So, Good point. So let's say you're driving in a car around a curve, right? You have an angular momentum that you feel this angular momentum. You want to keep going straight, but the car is curving. So to you, inside the car, you feel like you're sliding to the outside of the car. Enough so that if you had a camera inside of that car, you could measure the force that was carrying that person out. So you can measure the centrifugal force without a centrifugal force being present.
Or the other side of that is, or what they used to call centrifugal force, you are now calling angular momentum. Well, that is actually what's going on in the pseudoscience community.
Well,
they've changed the name of the force and applied the mathematical equation from one to another in order to disprove, centrifugal force doesn't happen. Centrifugal force is the same thing as angular momentum. It's the exact same force.
Right. You can use the same to calculate the other, but what we do is we use centrifugal force to explain what we experience inside of a reference frame. So inside of the reference frame, you feel like you're being pulled to the outside when you're not. You really just have a desire to keep going straight.
Well, you do, but you're going around a curve. That force is called centrifugal force.
Right. I understand, but what I'm saying is that you can measure that even though there is no actual force that's pulling you to the outside of the car. That's what I'm saying by a fictitious force.
No,
there's not actually something. Go ahead. I'm sorry.
If it was a tongue's getting all twisted here. If it was a fictitious force, it would not affect matter.
Meaning what?
Meaning you're using two arguments and bouncing in between the two. Physicist. Hold on, let me finish. any physicist will tell you that any real physicist will tell you that centrifugal force is absolutely a force, because they calculated for that when they allegedly launched rockets in an orbit. They didn't used to call it angular momentum. They didn't used to call it gravity or falling. They used to call it centrifugal force. Why? Because the outward force on an object, it doesn't matter straight or angular, although the calculations are different, okay, cause it to be held up. Okay, when I take a coin and I tie it to I'll give you an example of an experiment here. Coin, string, swing it around over your head. That's centrifugal force. What you call angular momentum.
That's two forces. That's centrifugal and centripetal. Hold on. Yes, that is centrifugal and centripetal. Yes, it is.
There is no centripetal force.
Let me ask you a question. Let me ask you a question. The moment you cut that string, what happens? Does the coin, does it continue on a circular path, or does it go straight?
No, it goes straight.
Okay, so without the centripetal force, you cannot have the centrifugal force.
Okay, thank you. So your centripetal force then is the string to which that is attached.
Yes.
Because that is, okay, all right. But that's not a force. That's an object holding it in place.
Oh, no. I beg to differ. That's a force that's holding that object together. Because if there was no force holding that object together, which ultimately defines what the centripetal force is, right? Because let's say you have a strength within the string. If you exceed the strength of that string, you break the centripetal force. Okay,
correct.
Yes, so there is a centripetal force that is holding it together that is measurable, and you can take that away, and the moment you take that away, you lose the centrifugal force as well.
Okay, here's what I'm going to tell you from all of my science background, are that there are words being added to the scientific community that are being imposed upon us to counteract the actual effects that we should be agreeing to, that we are not. For example, centripetal force is a new, within the last 15, 20 years, word it's being used. Okay, it was never, ever, ever an issue 50 years ago. You will not find it in any reference book, in any physics book 50 years ago, ever.
Okay.
So what I'm trying to say is a lot of flat earthers and round earthers arguments right now, and because what I'm really concerned about, Nathan and I've talked about this, is, dude, we're all humans on this earth. I don't give a damn whether you think it's round, flat. What I care about is the truth, and I'm like, I don't know if it's Team Skeptic, or I come from a position of, I don't care what you believe, but don't feel bad. I don't care what I believe. I only care about what is actually factual and true. Right. Why? Because anything that's not factual is a well, you call it satire, I call it fake, whatever you want to call it, I don't care. But the point is, there's been so many things added to us or given to us that they are playing off as true that are not true. For example, the Big Bang theory is still a theory. There's no proof of that.
It's backed by observational evidence.
No.
Listen, hold on. Okay. We can argue this point. Hey, JM, listen. I'd love to keep talking to you about this. You and I can have this conversation, and I'm sure that our audience would love to see this. So I intend on bringing you back. Nathan, I'd like to bring you back as well. I do need to close this down. I do have some things.
Team, can I just ask a question? Like, are you trying to say that centrifugal force and angular momentum are the same thing?
In essence, yes, they are.
No, because angular momentum is the angular quantity of motion, while centrifugal force is the force that keeps the body in the circular motion.
Yes.
The mathematical equation is the same. It's the same equation we used for centrifugal force. I would argue that that's the point I would argue with you.
Well, Craig, we'll have to talk about it next show.
Yeah. Listen, this is something I do have to get going, guys. This is something that was really great. Let me read out the super chats. JM, you're welcome to stay until I close it completely out. But give me 1 second, guys, to pull up super chats.
Hey, Team Skeptic, will you write my email down, so, like, get notified?
I emailed you. Did you?
I appreciate your grace letting me on. I was under the so thank you.
Hey, I emailed you, Nathan, so you have my email as well.
Okay, cool. Just like let's set something up within the next couple days.
Yeah, I'm down for that. I'm down for that. Hey, we have a new channel called Science or Satire. Eventually, we're going to be doing these streams on that channel, and I'm sure that would be a good idea to have you on. But let me go through these. I'm sorry.
Am I able to really plug my website? Because I actually have a website I do where I do scientific instructional videos.
Yeah, go ahead. Please do.
Okay.
Go ahead and I'll let you go. I'll let everybody do their you go ahead and promote your website. I'll do the super chats and we'll all say bye.
All right. My name's real quick. Oh, go ahead, Nathan.
No, go ahead, bro. I'll close out at the end.
All right. My name's Joshua Michael. I own a website called jmtruth.com. I do a bunch of several different series. One's called Science Series 101 and 100 and 200 series, physics and biochemistry. And then I have a series called my philosophy series, where I talk about philosophical issues, which are ethical issues. My YouTube channel is jmtruth.com, and you can also find me on Facebook as jmtruth.tv or jmtruth.tv on Facebook and YouTube. Sorry.
Wow. Hey, can I ask you a question? Are you a flat earther?
I have proven, at least as far as I can tell, the Earth is flat and motionless.
Okay.
Yeah.
Well, we'll have that discussion next time. I just wanted to know your position right now. All right, let me do super chats, and then I'm going to let everybody close out their channel. And Nathan, you'll be the last one before me, okay? Like, I'll finish it off to promote my channel, but you'll get that last word in. So starting out with Mike, I think that's where we left off. Mike, for $5, are you going to have a bell emoji? Yeah, I do have. Wait, Mike, what are you talking about? I do have a bell emoji. It's the skeptic ding. In fact, Ding Force, will you please flood Mike with the skeptic ding emoji, please? Because obviously Mike doesn't know what he's talking about. Because I think it's there. Lawrence Carrington for $10 to keep you promoting rational scientific conversations to those who need to know or refuse to see. Thank you, Lawrence. That's the whole purpose of me being here, is to have fun with science, but I generally want to promote good science. So, Mild Chestnut, you gave me a few euros today. I do appreciate that. The more the laser spreads, for €5, the more the laser spreads, the more chance for it to get diffracted by the air in favorable fashion. Scrat, the skeptic squirrel, $5. Nathan Oakley admitted on his broadcast from the 7 that he's a troll. Nathan, if you want to address that, I'll let you address that. But Nathan Oakley. I'm sorry, Nathan Oakley. That wasn't you. All right, B-Ball for Life, who I believe B-Ball for Life, I think I saw that you were a new member. I think you joined when maybe between live streams, so thank you very much for becoming a member of the channel, and I do appreciate your $5 super chat. Please watch Professor Dave Explains Globebusters response video, greatest debunk ever. I agree with you, B-Ball. It was a great video. I don't know why his channel was struck with the they removed the video for being spam. I don't know if he got mass flagged or not. I don't think anybody should mass flag anybody else just because they have a different opinion. But the video's back up. I would suggest everybody go watch it. I'm already working on a debunk video involving Globebusters, and it's going to be great, guys. I'm going to stand up for Professor Dave. He has too much integrity to stoop down to arguing with people like the Morgile, Jeranism, and Bob Nodell. So 0132 for $6.66, my favorite super chat amount all the time. Hurricanes rotate different directions in the northern and southern hemisphere. That's a natural application of the Coriolis effect. Yeah, that's a natural observation that we apply the Coriolis effect to explain. Mild Chestnut again for another €5. I think Mild Chestnut's consistently giving me super chats so that I learn the difference between the euro and the pound. I still don't know, Mild, so if you continue to educate me. Just kidding, man. Thank you very much. I appreciate everything you've done for me. Nathan can't explain 15 degrees per hour movement of the sun. B-Ball for Life for another $2. How do meteors not break through the dome, Nathan? Well, I don't think they believe in meteors if they don't think that space is out there.
That would be correct.
That would be correct. Okay. Knockdown Will for $5 Canadian. Save your $5 and buy some beaver repellent so we can get Brainy Beaver away from my channel. He spends too much time in my chats. And yeah, use that. You're closer to him than I am, so you have a better. You can just apply it to the local water supply, and that should take care of brainy beaver. But for $5 Canadian, the vacuum of space and a Bissell are two very different things, idiot. I'm not going to ding him here because we've all had this very polite conversation. But Willie Merck, $4.99, gas pressure with no container. Learn about the boundary layer on aircraft skin on a golf ball. Not to mention the fact that I brought up the sulfur hexafluoride in our debate on non-sec, or our discussion. I'm not going to call that a debate because neither one of us were prepared for that. We just went in there to have a conversation, just like we're doing tonight. It's just a conversation. We're just discussing our worldview, and I appreciate the dissenting opinion. Fletcher Eisler, who my only... Listen, I have one guy out there that I absolutely love more than all the rest of you idiots out there, and that's Fletcher Eisler, because Fletcher Eisler is not only a member of the channel, but he's also a member of my highest tier on Patreon, and he purchased a shirt. So,
hey, team.
Fletcher, yeah.
Oh, just to let you, and I'm not, because I don't want to get into this discussion until we come back, but I'm just going to let you know, I'm a 12-year military veteran with high special skills to be able to talk about certain topics that you've already mentioned.
Okay. Yeah, like I said, we'll bring you on for a future show, and we'll get you and Nathan back in here for a future show, so it's not really 2-on-1. It'll be more like a 2-on-2 discussion.
Wait, hey, just in case I was wrong, JM, is space a negative pressure system?
Absolutely is.
No.
Okay, all right, great. I was just making sure.
We'll talk about that.
17 negative torr is absolutely negative.
No. Hold on. Hey, that's not what he said, is it, Nathan? Say what you said about the.
He said you asked if it was a negative pressure system.
No. He didn't say it was negative 17 torr. What did you say it was, Nathan?
The whole time I've been saying
10 to the negative
allegedly...
17. Hold on. You said 10 to the negative 17. 10 to the negative 17. 10 to the negative 17th is a positive number, guys.
That doesn't mean negative. That's a positive number.
That's 0.0 with 17 zeros and a 1.
All right. We'll discuss this later.
Yeah.
It's a positive number to represent a negative pressure.
Correct.
It's a positive number.
That doesn't make sense.
That's correct.
Okay, Fletcher Eisler, thank you again for all your support, Fletcher. I truly appreciate it. The next live stream, I'm going to be putting Fletcher Eisler's picture on the screen with him wearing that really cool Team Skeptic merchandise. So I guess we'll start out with JM, since you were the last one to join the panel. JM, do you have anything to say before you step out of here?
My only thing is I would ask that we remember to love one another, and we are all on the same earth together. And instead of fighting each other, we need to be all seeking the truth together and not assuming that we know it, but actually proving it.
Okay.
Well said.
All right. Now, I guess we'll do Fight the Flat Earth. You go ahead and say your last goodbyes before they leave, and then we'll go ahead and step out after that.
Yeah, I'm all for truth and fighting for the truth, but when the truth is blatantly ignored and then nonsense is pushed as truth, then that's when people need to stand up and fight. I'm all for loving each other, but when people are going to be idiots, then they're going to get called idiots. Also, the formula for centrifugal force is Fc equals mv squared over r, and the formula for angular momentum is L equals IW. So they're very, very different equations, and I don't understand why you keep saying they're the same thing. But that's for another day.
It's the same thing as mass and weight. Mass and weight are exactly the same thing. And I can prove that before.
Hold on. I really do got to go, guys. So I want to give everybody a chance to say goodbye. So I guess Nathan, this is your chance to say your goodbyes, man.
Yeah, for sure. I don't think we need to fight each other. I don't think we need to call each other idiots. The only barrier from the truth is the preconceived notion that you already have the truth.
Correct.
So guys, it's been real having you on. Craig, you've been super cool tonight compared to what I've seen, and Team Skeptic above and beyond what I thought was capable from you, dude. So thank you. Thank you for having me on, dude.
Listen, Nathan,
really cool.
I want to, as I'm stepping out of here, I do appreciate you coming on. I wasn't expecting you to. I do appreciate it. But are you going to Dallas for the Flat Earth Conference in November?
I'm speaking on Flat Earth 101. I'll be one of the first people on.
Okay, so I'm trying to get together a friendly panel to at least represent our opposing opinion. I'm not there to troll. I'm coming from a very intellectually honest and integrity. I survive on that. Like I'm not here to gotcha, like Logan Paul or do all these other things. I want to bring people that are respected members of this community. I'm willing to pay for a booth. I'm willing to bring sponsors with me so that they can set up booths to help promote that conference and do what I can. But I want to go there and represent at least the opposing opinion and bring some of these guys that have the respectable members of the community to come down and just open up for conversation. I don't think anything is ever going to get solved over YouTube. I think that this is a great opportunity for us to begin discussions, but having a one-on-one or like a panel where we can all have a conversation where you can explain to me why I don't understand what you're saying, and I can explain to you why you don't understand what I'm saying, and other people can see it, maybe with some demonstrations or whatnot. I'd like to be a part of that, and I'd like to take part in that, and I think there's a huge part of this community that wants to see that. So maybe you should be the front runner on that and try to help me get that set up so we can all get together and have a drink, a laugh, and put on a great show for everybody.
I wish we could also realize that science is not a debate.
Hey, team, that sounds great. I'm down for that. And that's assuming you're not a flat earther by the conference.
That's assuming what now? Oh, no. We can put guarantees on that. When you guys can explain the when you guys can explain the equinox sunrise and you can explain the southern celestial poles, we'll have a conversation about my beliefs at that point. Because I'm open. I'm totally open to being a flat earther. All you got to do is prove it to me. If you can prove that the Earth is flat and that the globe is a lie, if you can prove to me beyond a shadow of a doubt by my own words, from the day I got into this, I've said it's not a belief system for me. It is an acceptance of a body of evidence, and the body of evidence, in my opinion, yes.
Can you act like this in the group, and we'll unblock you? You come hang out if you want.
No, I'm not kidding. We have mutual friends in real life, and I only went in that group because our mutual friend said, hey, go check this out, and then your buddy, who's her buddy too, was the one that booted me out, didn't even give me a chance to respond. And I wasn't even being an ass. This was before my channel. I wasn't even being an asshole.
Who do we know? Who's our mutual friend?
I can't say her name online. I don't want to put her out like that, but we can talk about that offline.
Right on. All right, cool. All right, guys. Is it my turn?
Yeah. Go ahead. You can you get that last little second.
Yeah.
I'm gonna say bye. I'm gonna say bye at the end, but I'll give you your chance to speak.
Yeah. Just want to say, guys, if you want to join the official Flat Earth and Globe discussion, check it out. Follow me on Instagram. The Globe is Flat. My YouTube channel, Nathan Thompson. And love all you guys. Thanks for having me on the show. Really cool to be here with you and Craig, acting cordial. So I'll see you guys later.
All right. Well, hey, we are doing, for the crowd out there, let me tell you, the last little bit is this Saturday, me and Conspiracy Cats will be doing a charity FIFA match. We're going to be playing a few games with some subscribers, and the winner, all Super Chats from that day will go to whoever wins, will go to their respective charities. So we're not sure whether we're gonna be doing it on my channel or if we're going to be doing it on the non-sec channel. But one of us will have that posted this Saturday. So tune in, please come and support charity. We're not keeping any money from that day. We're giving it all to charity. So other than that, this will be uploaded on the Science or Satire channel. Link is in the description. Subscribe if you haven't. Nathan, thanks for coming on. JM, same for you. Thank you. Craig, as always, bruh.
It was it was a good episode.
Yeah, great
nice to talk to you,
buddy.
All right, well, I guess we'll close it out here. Does anybody else have any last word?
It was just nice to meet you guys.
All right, same here, JM.
I'm
Team Skeptic. I'm Father Skeptic, and I'm
Fight the Flat Earth. Bye.
All right, I think we're clear. All right, guys, I have to get off. I'd love to. Oh, did I close it out? I sure did. I don't even know if I'm still streaming. Hey guys, I don't know. I think I'm still streaming. I think I accidentally just closed those guys out. So I'm Team Skeptic, and I rule. I rock. I just boot everybody. I just shut it all down. I left it all up for me so I can have this moment of joy and glory for you guys. Jesus loves you. Amen. I'll see you guys later.